All right, welcome everybody. I imagine a few that are still out socializing in the lobby will be making their way in here to join us in just a moment or two, but we're happy to have you here at the Health Science Center. This is Conversations about Ethics, and I am Ruth Berggren, the Director of the Center for Medical Humanities and Ethics, where we have a mission to teach ethics and professionalism while nurturing empathy and humanitarian values. Today's lunch seminar and the evening keynote represent actually the 14th installment of Conversations about Ethics, which explores ethical dilemmas that influence healthcare delivery. We present this series twice annually, together with the Ecumenical Center, and we're funded with the generous support of Methodist Healthcare Ministries. And if anyone from the Ecumenical Center or Methodist Healthcare Ministries is here this evening, we'd appreciate it if you could stand up and be recognized. If not, we do recognize our partners and we're grateful for their support. Now, there are a few housekeeping details. Dr. Joseph LeDoux and the Planning Committee have disclosed no relevant financial relationships with any commercial interests related to this activity. If you are seeking continuing education credit, please make sure to sign in at the appropriate desk back in the lobby as a record of your attendance. You should also log into the CME website 1 month from now to claim your credit, and this information is on the record of attendance form that hopefully you received as you entered. Please do not give this form back to us. It is strictly for your information to guide you to log into the website in a month when you can get your credit. For CEU credit, please fill out the survey provided at sign-in and return it to the CEU desk before you leave, and you'll get your certificate at that time. So if any of this is unclear, please see one of our volunteers at the table after the event. Tonight's presentation is titled When Memory Deceives, Current and Emerging Trends in Memory Manipulation. Researchers are finding that memory is more malleable than previously believed, subject to ulceration or possibly even erasure. And this can lead to therapies for post-traumatic stress disorder or dementia, anxiety. At the same time, our memories make us who we are. So manipulating them can raise some obvious ethical questions. Our speaker, Dr. Joseph LeDoux, is a neuroscientist who studies the brain mechanisms of emotion and memory. He is the Henry and Lucy Moses Professor of Science at New York University in the Center for Neuroscience and Director of the Emotional Brain Institute of NYU and the Nathan Kline Institute. He authored the books The Emotional Brain, Synaptic Self, and most recently, Anxious. I think I need to read that one. Some of those books are available for sale outside the lecture hall, and Dr. LeDoux has told me he will be happy to sign for you if you are interested after the lecture. Dr. LeDoux is a frequent contributor and commentator in broadcast and print media. In his spare time, he is the lead singer and songwriter for the band called the Amygdaloids. One final word before we welcome our speaker. I want to acknowledge the presence of NOWCast San Antonio with Charlotte Ann Lucas here. NOWCast has been gracious in documenting, recording many of the enrichment activities that we provide through the Center for Medical Humanities and Ethics. And Charlotte Ann has shared this flyer with me, which shows a nice review of many of the presentations that have been recorded and which you can access, including today's presentation, thank you, Dr. LeDoux, will be accessible at NOWCastUSA's website. All right, please help me welcome Dr. Joseph LeDoux.
Well, thank you very much, and it's been an interesting day already, and I hope to continue the discussion tonight. A few years ago, about 15 years ago, we did an experiment in the area that I normally work on, which is how the brain detects and responds to danger. Most of this work is done in animals, although we, through collaborative studies, try to extend the findings to humans as well. Now, in this one particular study, though, what we ended up doing was looking at the effects of manipulations of memory after it was formed and this was part of a scientific question. It had no therapeutic, we weren't interested in the therapeutic implications at the time, but it led to a kind of ethical, hoopla after we published this paper. So we got a little bit interested into the questions about the ethics of the research and thought about it a bit. But I'm not an ethicist, and I don't claim to have answers to these questions, but I'll explore some of the ideas. Most of the lecture will be about memory, but at the end we will get to the ethical questions. So I want to talk a bit about the memory and how we understand it, and I'm going to go pretty far back to Aristotle and Plato. So Aristotle compared the human mind to a blank wax tablet and proposed that all knowledge is acquired and written on this tablet. The tablet is like a memory warehouse in his idea. More modern metaphors include a filing cabinet or a computer hard drive. Plato also used this wax tablet metaphor, and he said, the gift of memory, the mother of muses, and that whenever we wish to remember anything we see or hear or think of in our own minds, we hold this wax under perceptions and thoughts and imprint upon it. Whatever is imprinted is remembered and known as long as the image lasts. So this view of memory as a fixed entity that's stored when we have experiences and retrieved when we remember is still very common, and it's the way that most of us think about memory. You have some kind of trace that is stored, and then when you retrieve it, you retrieve that thing. An alternative view came along in 1932 by Frederick Bartlett. He viewed memory as a construction. So his idea was that a memory is a constructive process when the person gives their opinion about what happened, along with additional influences such as their experiences, knowledge, and expectations. So it's not simply about retrieving the memory, but it also depends on the brain and mind that you're retrieving the memory into. And the fact is that the mind that retrieves a memory that was established 3 years ago is not the mind of the person that was establishing the memory. So lots of things happen to you. Your mind grows and learns and stores lots of things in the meantime, and these then influence the memory when you retrieve it. So we can contrast that traditional view with Bartlett's view, where memory contains a lot of different components. And when you retrieve a memory, you retrieve some of those components and sort of stitch it together into a whole that you then have as the memory. But the memory is based on this assembly of the various pieces, and only some of them are used. So it's not the same thing as the experience you actually had when you stored the memory. It's a different experience that you piece together at the time. And this creates the opportunity for misremembering. Now, a few years ago, Dan Schachter wrote a book called The 7 Sins of Memory, and he described a bunch of these things, which I'll go through. One is transience, which is the decreasing ability, the decreasing accessibility of memory over time. He uses an example of President Clinton's convenient lapses of memory during the Monica Lewinsky investigation. Another is absent-mindedness, lapses of attention and forgetting to do things. Where did you put your keys and so forth. This sin operates both when memory is formed and when we retrieve it or access it. An example he gave is, well, this is keys, as I said, but also Yo-Yo Ma forgot his $2.5 million cello in the trunk of a cab. I think he eventually was able to get it back then. Blocking is temporary inaccessibility, such as tip of the tongue phenomenon. Suggestibility, incorporation of memory that wasn't in the memory. Elizabeth Loftus has talked quite a bit about this in terms of legal proceedings. We have bias, which is distortions produced by current knowledge and beliefs that skew memory. Persistence, where unwanted recollections that people can't forget, such as unrelenting intrusive memories of trauma. And misattribution, where you attribute memories incorrectly, like a rental shop mechanic who thought that an accomplice known as John Doe No. 2 had worked with Timothy McVeigh in the Oklahoma City bombing. He thought he'd seen the two together in a shop, but in fact the mechanic encountered John Doe number 2 alone or in a different way, different day. So these are different ways that memory can be distorted or misrepresented or somehow changed over time. Now I want to talk briefly about how this relates to repression, recovered memory, and false memory. So repression is a defense mechanism, a Freudian defense mechanism in which troubling memories are prevented from surfacing in the conscious mind. So these are anxiety-provoking states, so they're shipped to the unconscious mind, at least according to the Freudian theory. And that means that if you have a memory that you've repressed, theoretically it should be possible then through therapy or other means to recover that memory. And this would be a process of gaining conscious access to something that you didn't have conscious access to before. Now the problem is some of the information you recover may be true, but some of it may not. And when it's not true, this is called a false memory, but it's very difficult to separate and distinguish a false memory from an actual memory. Because unless there's corroborating evidence by multiple sources, there's no way to really know how true a memory is if it's only in your head, because we can all be deceived, as Schachter's 7 Sins illustrate. Now, this is a very difficult problem in legal proceedings, especially when you depend on eyewitness testimony, where one person's eyewitness testimony is what the case is built on. Because that person's memory could be fallible in this very way. And so how can we accuse someone or convict someone of a crime like murder on the basis of one person's memory? This is not something I'll talk about again, but it's obviously a very important legal question, an ethical question. So why is memory so imprecise? I think the brain can help us understand this. So in neuroscience, it's a dogma that all aspects of mind and brain, mental life and so forth, behavior, are products of the brain. So we have to think, when we begin to think about how the brain does something like memory, we have to ask questions across 3 levels. The level of behavior, the level of brain systems and brain areas, and the level of cellular mechanisms and molecular mechanisms. Now, usually you would think of a neuroscientist as having a reductive approach, where you start with the behavioral level, you then find out the brain systems information about how that behavior is represented and controlled, and then once you've found the cells and molecules that are involved in that brain area that control the behavior, your job is done. But that's not the way that I think about the brain, and I think a lot of neuroscientists today probably would agree that we think of the brain, we think of our approach to the brain as more of an integrative rather than a reductive approach, where information about behavior can help you identify, say, genes that are underlying that behavior, because you have to have very sophisticated tasks to separate the contribution of different genes. But at the same time, revelations about the genes that are involved in a behavior can dissect or separate the behavior itself. So if you have a behavior and you find out, or you have several behaviors and you find the genes that are related to them, you may find out something about each of those behaviors that you didn't know from the behavioral study alone. A good example of how the brain can help you in this way was the patient HM who lost his ability to form conscious memories as a result of having the hippocampus in his brain removed on both sides due to intractable epilepsy. But what we learned from this patient is that short-term memory, which is a temporary memory, is unaffected by this kind of brain damage. So the hippocampus is not involved in short-term memory, but the hippocampus is involved in the formation of new long-term memories. So this studies of the patient and his brain disorder helped us understand a psychological phenomenon. Short-term memory is very distinct from long-term memory. This has been speculated on for a long time, but the actual neural basis of it could not be uncovered until this patient had come along. So we're going to ask 3 questions about memory: what, where, and how. So what is, where does the memory occur? And to do that, we want to think about the fact that memory occurs in phases. So if we want to understand what, we have to understand differences in the kinds of memory, the phases of memory. So the acquisition of memory is going to involve different brain mechanisms than the consolidation or storage of the memory. And that may be different from the systems that are involved in retaining the memory, and still different from those that may be involved in retrieval. And there are other processes like decline, forgetting, and so forth. So we need to have a very good psychological conception of the process we're interested in studying if we want to understand that process in the brain, because our ability to understand how the brain mediates any behavior or mental state is only as good as our understanding of the behavior or mental state psychologically. So here are the stages that we just described. Acquisition or learning. So during acquisition, a short-term memory is created. During consolidation, the short-term memory is created into a long-term memory that can persist. Then at some point you may retrieve the memory, and over time the memory may decline, or it may not. Sometimes they do, sometimes they don't. Another, in terms of the what question, we can classify memories in different ways. By time, into short and long-term memory. By type, there's associative memory and non-associative memory, and by relation to awareness, where some memories are implicit or do not involve awareness, whereas others are explicit and do involve conscious awareness. So let's talk about awareness for a bit. Explicit memories depend on conscious awareness for the formation of the memory and for the retention or for the retrieval of the memory later. So if you don't form a memory in your conscious mind, if your conscious mind isn't involved in the formation of a memory, your conscious mind can't later retrieve that memory. So there's no way to unconsciously learn and then consciously retrieve. So in order for you to recover a memory, you have to have first stored that memory in a conscious way, and then for whatever reason, that memory is either forgetting, repression, or a lot of other things. That memory may be weakened, so it's inaccessible, but only if it's consciously formed can it be consciously retrieved. Implicit memories, on the other hand, do not depend on consciousness. So I'm not talking about the Freudian unconscious here when I talk about implicit memories. I'm talking about things like learning how to ride a bicycle. This is something that you start out, every movement is planned, you're trying to balance, the conscious mind is involved there. But as you begin to learn it, you learn it as a motor act. Well, so you sometimes hear about muscle memory. It's muscle memory, but there's no muscle memory. Muscle memory is in the brain. The memory of how to control the muscles and use them is in the brain. So it's metaphorically muscle memory, but technically it's brain memory. So most memories are like this. They're stored by systems that operate non-consciously. If, for example, you're walking down the street and your neighbor's dog bites you, the sight of that dog in the future will cause your heart to race, your palms to sweat, maybe you'll freeze and be agitated and so forth. So all of these things are being formed non-consciously. They may also be at the same time being formed consciously, but it's through different brain systems. So let's look at this in a little more detail. So this, we have explicit memories, and there are two kinds One is episodic memory, memory of the episodes of your life, your personal experiences, your last birthday, your anniversary, what you had for lunch today, or your favorite restaurant, memory at your favorite restaurant. And these contrast with semantic memories, which are memories about facts, just details. An implicit memory, there are a lot of different things that fall under this. Conditioning, like the dog bite example. Habits that you may learn through that become things that you learn how to do that become habitual. For example, an addiction is a habit that you can't break. It's in your brain. It's different from an associative conditioning thing. It's a different kind of behavior, and it's not conscious. It's simply, that's why you can't simply tell yourself, I'm not going to be addicted to cigarettes anymore. Once it's become habitual, your brain is doing it. You're not in charge. It's your brain that's doing it, and you have to, if you're going to undo that, you have to be able to attack the unconscious mind, the non-conscious mind. The same with conditioning. If you've been conditioned by some traumatic event to some trigger stimulus, no amount of therapy is going to get rid of the conditioning to that stimulus, no amount of talk therapy. You're going to have to decondition that stimulus through behavioral exposures and so forth, and separately train the cognitive mind to deal with it. Skills like playing chess or riding bikes and playing an instrument and so forth. And then something called priming, where information that you know but don't necessarily consciously access helps you solve a problem. So let's look at examples of episodic versus semantic memory here. So you could read a book about weddings and marriage and so forth, but that's not the same thing as your own wedding or marriage. You could read a book about coming to Texas, before coming to Texas, but your personal experiences in Texas are a different thing. And these are stored in different parts of the brain and different systems. They're interrelated, but they're different systems. But both are consciously accessible memories. They're memories that you consciously form and store, and also that you consciously retrieve. Associative conditioning, which I've talked about a bit, this would be an example. You're in an automobile accident. You'll still have a conscious memory of that accident. So, kind of car. That's it. My typing is, sorry, I went through this quickly. Kind of car you were in, who you were with, where you were going, location of the accident, that it was awful. These are all facts about the experience. These are semantic memories about that experience. But there could also be episodic memories, the fact that it was awful, the things that happened to you. You remember the event itself. At the same time, a non-conscious memory is being formed. The stimuli at the location can re-trigger the brain and body responses, for example, and these are non-consciously controlled. The body and brain arousal can amplify the retrieved conscious memories, though, so the two systems can interact. So here we have explicit memory, conscious memory of where you were and who you were with and all of that with the accident, non-conscious memory that caused you to sweat and so forth. And so let me go back. And this kind of memory, to the extent that it's releasing hormones and increasing brain arousal and so forth, can influence the strength of the formation of this memory. So that when you then later retrieve this memory and then automatically activate this memory as well, you create a loop of arousal so that each retrieval makes the memory stronger. And this is why it's so hard to get rid of these memories, because they are self-perpetuating, because the conscious memory and the implicit memory are coming online at the same time. So different brain systems. The hippocampus is involved in these explicit memories. Areas related to the hippocampus, like the entorhinal, perirhinal, and parahippocampal cortex, are involved in semantic memories. So episodic and semantic memories both involve the temporal lobe, but different parts of the temporal lobe. The amygdala is another temporal lobe structure, but it's involved in these associative conditioning memories. So we know a lot about how to separate these things in terms of what they are, what are the basic behavioral principles underlying these memories, where they're located in the brain, and here's the hormone picture and how they might interact to some extent. Now, there's some interesting things about these two structures and their contribution to memory. So damage to the hippocampus leads to the loss of the conscious memory about the experience. So if you, again, using the accident, if during the accident for some reason your hippocampus is damaged, then you won't be able to remember the details of the accident. But if you go back to that intersection or see that kind of car, you'll still have all the body arousal and brain arousal and so forth that goes with that. On the other hand, if you have amygdala damage, you won't have any of this brain arousal and body arousal stuff, but you'll still be able to remember the details of the accident. So these are two kinds of memories. One is contributing episodic information and semantic information, conscious information that you can later retrieve, and the other is contributing non-conscious information that generates a bodily response that is part of what you might typically call the fight-flight response, because it's preparing you for the danger. The reason your amygdala is learning these things is because it's useful in a situation of danger to store that kind of information and then reactivate your body and brain in this kind of arousing way to help you cope with a future situation that you're in now, or a situation in the future that mimics this situation. So here's a drawing where half of the brain has been removed. For example, in this case, imagine the brain is like a hot dog bun, and we've removed one side of the hot dog bun. And so we are looking at the middle part, the untoasted white part of the remaining hot dog bun. But we've left the hippocampus and amygdala attached from the part that we've removed. So here's the amygdala, here's the hippocampus. Got the same structures on the opposite side. So most brain areas are dual. You have one of each on each side. To put it more in perspective, if an arrow were to go into your eye and your ear, where those arrows converge on the same side of the brain is roughly where your amygdala is. Same on the opposite side. Now, the amygdala is often described as an almond-shaped structure. The word amygdala is ancient Greek. It's from the ancient Greek word for almond. And you can see this almond-shaped thing right here. The almond-shaped part is really only one part of the amygdala. It's not the whole thing, but it carries it's the term that applies to this broader area that involves the almond shape. Now, the amygdala develops relatively early in life. It's there shortly after birth, or within months it's been wired up. Whereas the hippocampus matures a lot later. And this has often been described as a way of accounting for what Freud described as infantile amnesia, the inability to remember information that happened in your very early life. Roughly age 3 or so. Before that, most people have trouble remembering. But it's not an exact date. It's not like on your 3rd birthday your hippocampus is now mature. So there's a wide range of when this is taking place. But what's interesting is that a child that's abused at a very early age obviously can't remember it if the hippocampus is not there, can't consciously remember it. But the amygdala can form those associations that the child will then carry forward throughout life and constantly being re-triggered by the events that are part of this abuse and never being able to consciously recall it or understand it. Now, stress has different effects on these two structures, which is very important. Stress will impair the hippocampus. So when stress is prolonged or especially intense, the hormones released during the stressful event, especially cortisol, will be released into the body from the adrenal gland, go into the bloodstream, make its way back to the brain, and bind to receptors in the brain in quite a few brain areas. But when they bind to the hippocampus, if there's a strong surge or the surge continues over a prolonged period of time, the dendrites, which are the kind of antenna sticking out of the neurons in the hippocampus, will begin to shrink. And these will shrink and shrink as long as the stress persists. This is through the work of Robert Sapolsky and Bruce McEwen and many others. And so as the dendrites shrink, the cells begin to lose their ability to do their job, which is to form these conscious memories. Now, if the stress is discontinued, the dendrites will grow back. But if the stress is prolonged and continuous over a long period of time, then the cells will actually begin to die, and this will be irreversible. So this is part of the reason why in a very stressful situation, one, say a mugging or some kind of torture situation, a person could have an amnesia or a partial amnesia for that experience because the hippocampus isn't able to do its job properly. It isn't able to completely form a memory that it's trying to form because of the stressful hormones that are being released. Whereas the amygdala is perked up by these stress hormones, so it does its job better. So the exact same condition that is creating a very strong, quote, emotional memory is weakening your ability to consciously process and understand that situation. So again, if you're in a therapeutic situation and you're trying to recover those memories, it's very difficult because the hippocampus wasn't performing properly during the experience, so it didn't form a memory the way it should have. However, these hormones take a while to kick in, so it's not like it's not like no memory was formed. Maybe memories were beginning to be formed before the hormones kicked in. And maybe only some of the cells were affected, or maybe the effect was weak at first, so that you're beginning to form a kind of memory. But if you remember at the very beginning, when I showed you the reconstructive nature of memory, you've got to piece those pieces back together. You've got to reassemble that memory. And if the stuff you're starting with is corrupted, you're going to have a hard time reassembling it. And this is where the opportunity for false memory or inaccurate memory comes in a situation like this. So one of the important points here is that repression is not the only explanation for why one might not remember a very traumatic experience. I'm not saying repression doesn't exist. That's for other people to decide. But what I'm saying is that extremely stressful situations can biologically alter the ability of the brain to form a memory. And as a result, you have something that looks like repression, where the person was traumatized during the experience and is unable to retrieve the memory, has an amnesia for that memory. So that may be why there's sometimes confusion about exactly what the cause of an amnesia is. So, and again, after the experience, you may not be able to remember the details because of the stress hormones. The stress hormones are interfering with this, and the amygdala was facilitated, rather impaired, so that each time you retrieve, you have another surge of stress hormones that then can do the same thing. So, and as I said, some of these effects are slow, so it won't completely eliminate the memory. Now, in a sense, all memories are false memories to the extent that they're a reconstruction. They're not a carbon copy of the original experience. You have to always piece them back together. And it's just a matter of degree. I mean, some memories are only a bit false, whereas others are, quite a bit false. Why would the brain be established in a way to create memories like this? Why is the brain inaccurate in memory formation, since memory is so essential to life and survival? Well, this is where the study that I mentioned at the very beginning becomes relevant. So this was done by Kareem Nader, Glenn Joesph, and me in 2000. And what we did was, in the study, we revived interest. The results of the study revived interest in the topic of reconsolidation. So, again, the traditional view, you retrieve a carbon copy of the memory. The Bartlett view is that you reconstruct. And the reconsolidation research that we did was very consistent with Bartlett's original idea. So this work was done in rats in a procedure called Pavlovian threat conditioning, where the rat is in a chamber, and on the first day it's habituated, so nothing is going on. It's not freezing very much. Freezing is the measure of the rat's threat response here. During conditioning, the rat hears a tone, and then it gets one mild foot shock. This is to simulate an experience where the rat may have been out in the wild, and it's attacked by a cat, and the cat wounds the rat as the rat actually makes an escape. So the mild foot shock is simulating the wound, and the sound that we play in association with the foot shock is simulating any kind of environmental stimuli that might have been around at the time that the rat was wounded. So when the tone occurs again, the rat freezes. Freezing is a very effective defense response against a predator. If there's a predator immediately present, freezing will buy you some time because the predator is less likely to attack you if you're standing still than if you're trying to escape. As soon as you make your first escape response, the predator will pounce. So it's a very useful strategy, and in fact, it's done by almost all vertebrates, and including some invertebrates like flies will freeze in the face of a predator as well. So the consolidation process is the first thing we need to understand because reconsolidation builds on consolidation. So again, during learning, you begin to form a short-term memory, and then a consolidation is the process of converting that short-term memory into a persistent long-term memory. You can then retrieve that memory later, and once you retrieve the memory, that's when the reconsolidation process kicks in. Normally, all other things being equal, reconsolidation is a way to enhance your memory, to either update it, modify it in some way, or to change it otherwise. But it's a process of keeping the memory strong. If you block the reconsolidation process, you weaken the memory. And this is where the idea of memory erasure comes in. But I'll say right from the bat, no one has ever, as far as I know, truly erased a memory. Even in the rodent studies, we don't erase the memories, we dampen these memories. And we're going to talk about this, so don't jump the gun too much here. So here's how the consolidation experiment works. You train, so the tone and the shock are presented. Then the drug is given immediately after training. This is a protein synthesis inhibitor. And the reason for that is that protein synthesis is required for the formation of the memory. Now, this had been, the role of protein synthesis in memory had been known since the 1960s. And so in this experiment on consolidation, which Glenn Joesph did the year before the reconsolidation experiment, our only advance here was to be able to manipulate that memory directly in the amygdala, because we had shown that the amygdala is the site where that memory is formed. So we wanted to test whether blockade of protein synthesis at the site where the memory is formed could block the consolidation of the memory. So we injected the protein synthesis inhibitor directly into the amygdala and then tested short-term memory and long-term memory. So short-term memory, long-term memory again. If you give a consolidation blocker, the idea is that short-term memory will be intact because short-term memory does not depend on protein synthesis, whereas long-term memory will be interfered with. So that's what we found. So short-term memory was not different in the vehicle, which is basically the placebo group, and the group that received the protein synthesis inhibitor, anisomycin. Whereas long-term memory is impaired in the group that got anisomycin in the lateral amygdala. So this replicated the standard memory consolidation result that had been known, as I said, since the 1960s. But all of those other studies had been done using systemic manipulations. You know, the effect of you taking a pill or getting a shot, the drug will then go into your bloodstream and affect your entire brain and body. So we were able to target specifically the part of the amygdala that was involved in the formation of the memory. Now, in the reconsolidation experiment, you don't do anything after learning. You wait some period of time, you know, a couple of days, for example. Then you present the tone, so the rat is now retrieving the memory. Then you block protein synthesis immediately after retrieval. Then you test short-term memory and long-term memory post-retrieval. And if the reconsolidation blockade works, you should get a weakening of the memory after retrieval. And that's exactly what we found. So post-reactivation short-term memory, no effect. Post-reactivation long-term memory is impaired. So what this means is that we needed to change the standard view of memory consolidation. So here's the traditional view. You learn, you store, you retrieve, and if you retrieve some later point, you retrieve what you stored initially. This is like the Aristotle-Plato idea. You stamp something in wax, and you know, each time you retrieve, you're retrieving that item that you stamped. The reconsolidation view suggests instead, you learn and you store, then you retrieve, and then in the future, when you retrieve again, you retrieve what you stored after the last retrieval. So if this idea is correct, it means that your memory is only as good as your last memory of that experience. So each time you retrieve a memory, again, as I said at the beginning, and as Bartlett said, you're in a different context. Your brain has learned a lot of things in the meantime. You're a different person today than you were 5 years ago. You know a lot of different stuff. So you have to update that memory. And that's what this reconsolidation process is for. It's not for eliminating memory or dampening memory or erasing memory. It's for updating memory and improving memory. That's why evolution made the brain work like this. Now, the idea has resulted that this might be useful in something like post-traumatic stress disorder and any kind of condition where one is troubled by memories. So the idea would be that you learn, you store, you retrieve, and then after you retrieve the memory of your troubling experience, you give a drug. You can't give protein synthesis inhibitors, as I'll explain, but you can give a drug like propranolol. And so go back. And theoretically, that should prevent the restorage of the memory and then prevent the retrieval of the memory later if you block the restorage after retrieval. So why use propranolol instead of a protein synthesis inhibitor? The protein synthesis inhibitor is toxic. Every cell in your body depends on protein synthesis to carry out its function. So if you were to give a person a protein synthesis inhibitor systemically, you might make them very sick. You couldn't, at this point, directly inject a protein synthesis inhibitor in the amygdala. Maybe you'll never be able to do that ethically, I'm not sure. But that would be a way to reduce the toxic effects because you're injecting such a small amount at that point in the rat that the rat is no longer sick from the protein synthesis inhibitors. It's in the brain, it's in a tiny little area of the brain. You're injecting maybe 25 nanoliters, which is a very small part of a milliliter. So why use propranolol? Well, norepinephrine, what propranolol does is it blocks norepinephrine, and norepinephrine modulates protein synthesis. So if you block norepinephrine using propranolol, you might then short-circuit that protein synthesis process with a drug that's safe for use in humans rather than having to give a protein synthesis inhibitor. So, is it effective? There have been promising results in clinical studies, but questions remain about the experimental designs that have been used so far, and not all the studies have given a positive result. So it's still a work in progress. Are there other possible agents that are safe? Cortisol actually can be used, effective in animals, and so is rapamycin. I don't think there are studies in humans yet, but both of these drugs are used in people, so they're potentially usable in a human trial. But it turns out that there's a non-drug approach that's also possible, which involves a combination of reconsolidation and extinction. And that's what I want to talk about now. Now, psychotherapy is often an effort to change memories. You may have troubling thoughts, which are themselves memories, they recur, or troubling behaviors like habits and so forth. So you need some way to change this, and this is what a therapy session often is about. And a common therapy used in, for example, in the treatment of problems with fear and anxiety is cognitive behavioral therapy. And a key technique in this procedure is exposure to the trigger stimuli to weaken their impact. So the idea is that maybe exposure can be combined with reconsolidation without drugs to alter memory. So here's Gary Larson's idea about exposure therapy. Professor Gallagher and his controversial technique of simultaneously confronting fear of heights, snakes, and the dark. So that's the basic idea. In a rat study, for example, you would condition the rat and then begin to present the stimulus without the shock. You present the tone over and over again, and the rat stops freezing to the sound. And basically that's the principle underlying the exposure component of exposure therapy. Now, I need to say right away that exposure therapy in a human is much more than extinction. There's a lot of relaxation training, a lot of talk therapy that goes with it. So we're only talking about the application of the extinction part of exposure therapy to humans, not about the entire process. But this may be useful. Why do we need to improve extinction? Why can't we just use extinction itself, since it's a well-known form of therapy, or part of a well-known form of therapy? The first problem is spontaneous recovery. So you can completely, and Pavlov discovered this in his studies in the 1920s, that if he completely extinguished a dog's response to the bell, for example, that had been paired with meat, if he waited a few days, the response would pop back up. And so you have to keep extinguishing over and over again. But even if you do this and you completely extinguish so that it's not happening at all anymore, stressful events can turn good extinction into poor extinction. So our trigger stimuli that are encountered, that are related to the original memory, can cause the recovery of the extinguished memory. So this is the level of the memory, and you basically bring it back to the pre-extinction level, or close to that. So while it's effective, when in the therapist's office, when the patient goes back out into the real world, the effects can be undone by various things, either the passage of time or various trigger stimuli that are encountered. So as obviously exposure is changing memory, but it's a molecular process in the brain, just like everything else the brain does. So maybe drugs can be used to make extinction more effective and thus reduce symptoms. And there are a lot of drugs that have been tried. One of these that's been somewhat successful is something called D-cycloserine. And this was discovered through rat studies by Michael Davis at Emory, that if he gave a drug like D-cycloserine, he could facilitate the extinction process and make it less likely that the rats would recover their threat responses on the basis of triggers and so forth. This has been taken into the clinic, and so people with phobias, for example, by Barbara Rothbaum and Carrie Ressler at Emory, they've shown that D-cycloserine can enhance exposure therapy. But still, it's not perfect, because these things will again recover. They can facilitate the learning and make it somewhat better, but it doesn't prevent the problem of recovery. So we accidentally discovered that if we combined extinction with a reconsolidation retrieval trial, we could eliminate the recovery and keep extinction, make it essentially permanent, or as permanent as we've been able to test. So how do you do this? So again, here, this is, well, we've already talked about spontaneous recovery, so I don't need to go there. The idea would be that you train, or the training occurs in life if you're a person, and you wait some period of time and retrieve the memory. In other words, a long-term memory test is a retrieval trial of the memory. And in a reconsolidation experiment, you would give the drug. But this is the reconsolidation retrieval trial. And so maybe it's possible. And so let's talk about what happens when you give the drug. What you're doing is changing the ability of that memory to persist. And you have, I should put it on here, but you have basically 4 hours in order to change that memory. Because what happens is the first trial here, the retrieval trial, sets into motion a molecular process that takes at least 10 minutes to trigger, and then will persist for 4 hours. If you wait 4 hours to give the drug, you can no longer get the reconsolidation effect. So there's a reconsolidation time window of 4 hours. So maybe instead of giving drugs and trying to block reconsolidation, maybe we can take advantage of the positive aspect of reconsolidation, the formation of the new memory. And what we want to do is extinguish the memory here and let that memory that this sound or this event is now safe rather than dangerous. So we open the reconsolidation window by presenting the retrieval trial, and now we have 4 hours to change the memory from danger to safe, and then at some point later, test how that worked. I guess I don't have the slide I wanted to have here. So this study was done by, oops, I'm going the wrong way. Sorry. Okay. So Daniela Schiller and Marie Montfield and Liz Phelps did a study in humans to test this idea. I'm going to take this slide off because it's distracting. What they did was they did the same thing that we did in the rats. They conditioned people to a picture. They waited a couple of days. They brought them back into the laboratory, retrieved the long-term memory. In other words, they initiated the reconsolidation trial process with one trial of exposure, one trial of the retrieval. They then either extinguished immediately afterwards, 10 minutes afterwards, 3 hours afterwards, 6 hours afterwards. If they did it 10 minutes, 1 hour, 2 hours, 3 hours, the memory never recovered. Extinction was permanent. If they did it 6 hours afterwards, there was no effect. The memory, in other words, the memory recovered. So building on this, researchers in China and at NIH did this in drug-addicted rats. They exposed the rats to, and one kind of study you do in drug-addicted rats or people is try to extinguish the drug memory. So, for example, paraphernalia cues or relapse cues, as they're called, are presented to a rat or a person over and over again to extinguish the drug-related memory. And this doesn't work very well. But they tried doing extinction the way we did it. In other words, they waited 10 minutes or 3 hours or 6 hours. And in the rats that they waited 10 minutes or 3 hours, but not 6 hours, the rats no longer relapsed in the presence of a tone that had been paired with cocaine. And so they were encouraged by this, and they did a study in cocaine-addicted people and did the exact same paradigm. If they did the extinction within 10 minutes and 4 hours in the people, the people were less likely to relapse when exposed to paraphernalia cues than if they did the process less than 10 minutes or more than 6 hours. So these simple little experiments in animals can have profound implications for understanding how to treat people. And now we get to the question of, should we be doing this? So the publication of this paper by Nader and Joesph and me in 2000 triggered a kind of a big debate on this topic about memory manipulation. A trauma therapist wrote in the New York Times afterwards, what would it mean for a Holocaust survivor of 5 decades to suddenly have her memory of the horror erased? George Bush's panel on bioethics weighed in. Memory is central to human flourishing because we pursue happiness in time. As time-bound beings, we can't forget our past. But they did also allow that traumatic memory can cast a shadow over one's life. So this is the balance that has to be considered. So, the fact is that conscious memory is less affected by these manipulations. All of the studies that we've done in rats are based on these implicit memories controlled by the amygdala, not complex conscious memories. And when the studies have been done in humans, the same result has been found. The people are less likely to show heart rate or sweating responses to the tone paired with a shock, for example. but they still remember the event. So propranolol in people will weaken the arousal response triggered by the amygdala, but not eliminate the conscious memory of that experience. So these tools do not cause forgetting of who we are. Instead, what they're simply doing is dampening the emotional impact, the non-conscious impact that is being triggered simultaneously but separately. Now, it's possible that new tools could come along that could make us forget who we are, but that's for somebody else to discuss later. A lot of people have weighed in on this topic, and so I'm going to go through some of the comments. The possible misuse is a big topic. So Debish and Ultima say, interference of the emotional impact could affect the way conscious memories, the way we consciously remember things. But that's exactly the point of these kinds of studies, to activate the non-conscious systems so that the conscious systems are less aroused and less impacted. A more legitimate concern to me is that memory blunting drugs could be used by trauma perpetrators as well as victims, for example, to relieve guilt on the basis of on the part of the perpetrator. They point out potential benefits. Reduction in arousal, fear, and dissociation by triggers may allow through psychotherapy the opportunity to experience a more complex and integrated response, such as sadness, anger, or remorse. So a person who is deeply traumatized and constantly having recurrent thoughts, and the mere therapy, going into a therapy session is just another trigger to revive all these memories and thoughts, is going to interfere with the ability to process this experience in a more reasonable way, where you could actually experience sadness, anger, or remorse, and perhaps come to terms with it more. So we have to find ways to alter the non-conscious processing systems in the brain so that the conscious mind can then more fully understand, comprehend, and move forward. Eric Perrins of the Hastings Institute is an ethicist there, and he points out that he distinguishes memory blunting from erasure, which is a very important distinction. All of the research is really on blunting, so the worries about erasure are not real worries, at least at not this point, and argues that blunting may be acceptable in some situations. So he supports a pill that would help soldiers, for example, with PTSD. He notes that inevitably there's a zone of ambiguity in which reasonable people will reach different conclusions about whether the intensity of a person's response is proportional to the trigger and thus should be treated. That's his sort of gold standard. Is the response proportional to the trigger? And so he contrasts, for example, the trauma experienced by someone who has been raped or tortured from the humiliation that someone may have in the workplace. This, he would say, may be less proportionate. The response, if you're saying you're traumatized by your boss, that may be out of proportion in his mind to the trigger in relation to the proportion that a person who's been raped or tortured experiences. He assumes the difference between psychological, non-physical, and medical or physical conditions that result in bad memories, and is more willing to go with the physical than the psychological. I don't buy this particular distinction because, all experiences are physical in the sense that they come in from the physical world, they're processed by the physical brain. Our perceptions are physical, our memories are physical, our consciousness is physical. As a neuroscientist, these are my core beliefs and principles. So I'm not really sure that we need to go down this road, although I guess that's kind of what he has in mind when he's talking about humiliation versus torture. He concludes that it may be best to leave the decisions about ambiguous situations to patients and clinicians. And that seems like, at this point, a pretty good conclusion to reach, that I don't think we're in the position at this point of having tools that are so powerful that we need laws or we need strict criteria, because these things may help people, but it may be very individualistic, and there's very little harm that can come from giving a drug like propranolol to a person after they retrieve a memory. Adam Kobler of Brooklyn Law School raises concern. Soldiers may feel less concerned about killing if they knew they could erase the memory. That's a legitimate concern, it seems. He cites a case where a woman was given a sedative that blunts memory so that she would not remember the tactless way she received a cancer diagnosis over an intercom in the office. I think she overheard this while the doctor was talking to someone else. So, nevertheless, he thinks that the drug should be pursued because evidence shows that people can be helped, and there are ethical issues to not treating people when a treatment is available. People are more likely to lose themselves to trauma than to the blunting of an emotional impact of a memory, he says. There's probably some truth to that as well. It's illegal to administer drugs without consent, so he's not too concerned about this as a major problem in this field. And most treatments have side effects anyway, and the patient can choose to have or not have. If the side effect is perhaps you will lose some aspect of your memory, even in your conscious memory. Do you want that? Are you willing to sacrifice some aspect of what you can remember to be less troubled by these other memories? That's, again, seems to me between the patient and the therapist. So here's my kind of final take on this. We create and change memory every time we interact with another human. It's just part of life. It's not an unusual kind of situation. Every conversation between two people is a memory-forming experience. And sometimes it's in an argument. It's an explicit memory change experience. You're trying to change the other person's attitudes, beliefs, so forth. Every therapy session is an effort to change memories, habits, recurring thoughts, sometimes replacing trauma triggers with safety signals or bad memories with good memories. These are common practices, so it's not really, you're not really doing anything else when you do a reconsolidation kind of procedure, just doing what the therapist normally would do with the addition of a relatively safe drug 1 or 2 times. This is not drug therapy. You're giving the drug 1 time or 2 times or however many times you retrieve the memory, but it's not something that the person is then on as a treatment. It's simply a way to enhance a process. The concerns are usually about drugs to change memory, but why is changing brain circuitry and chemistry underlying disturbing memories with drugs more undesirable than with talk? I mean, you could argue about that, I guess. But the point is that we can now do this reconsolidation kind of procedure without drugs at all. And it seems to be even more effective than with the drugs by combining reconsolidation with extinction. So there may be no need to discuss the drug issue. Again, as I pointed out, the techniques are not so powerful as to be able to change personality, certainly not at the moment. If the techniques turn out to be useful in humans, why is changing a memory ethically worse than removing parts of the brain that are diseased, as in epilepsy or cancer? This is much less invasive. After successful treatment, people with medical illness can often live normal lives. Untreated psychological disturbances prevent normal life. So why do people with psychological problems have to forego potential treatment? And I'll stop there. Thank you very much. Questions? Yes?
Could you say something about the role of sleep and dreaming in consolidation?
Right. So it's long been known that during sleep, memories are consolidated. And so if you don't sleep well, you may notice you don't remember quite as well. This is not just because you're tired, but because your brain is not effectively forming memories as well. And it's also true in reconsolidation, that you reconsolidate after sleep as well, or during sleep. But it's not about dreaming, though, because it used to be thought it was REM sleep that was important, but now slow-wave sleep seems to be equally, if not more important than REM sleep in consolidation and reconsolidation. Now, an interesting twist to all this is that given that a therapy session is a session where memories are being formed, especially if you're doing something like exposure therapy, you might be able to make those sessions more effective by introducing a sleep session afterwards, or even doing the therapy in the patient's home and allowing them to go to sleep, because when the patient, even after sleep, goes back out in the world, there may be triggers or other things that interfere retroactively with the memory, the good memories that are being formed during the therapy session, and weaken the therapy session. So doing it at home gives the person the opportunity then to sleep without these other disturbing interfering factors. Yes?
What does extinction look like at the reconsolidation with a complex trauma?
Well, so these things are limited to things where you have a trigger. I guess I should say that. You can't, now, but that said, let's take a complex trauma. There are going to be little triggers in that. So rather than, one of the things I argue in my book, Anxious, is that you shouldn't be trying to treat the trauma, but instead, the first thing to be done is to kind of try to get rid of the triggers individually, because we don't have tools that can effectively, weaken the whole thing. So you selectively kind of chip away at the triggers, maybe even start with the weaker ones first, so that you're not introducing flooding and so forth. But there, I'm sort of saying this out of context, but there's 3 chapters on this kind of stuff in the book.
And then my second question would be, part of my conceptualization of reworking a trauma like that is the patient does it with hopefully me a good contact, at the same time they're reworking this negative one. What does the drug then do to the establishment of that kind of connection?
Very good point. I don't know the answer to that. None of this has been done in a therapeutic situation. There have been studies with patients, but these are laboratory studies where the patient would come in and through script-driven imagery, remember the trauma would be reactivated, and then the drug is given after the reactivation. So that's one way you can do the bigger trauma thing, where you're not necessarily doing triggers, but you're letting the person reactivate internally. But again, now we're talking about a difference here between remembering in the conscious sense and what we can do with a drug like propranolol, which is change the arousal. So both of those things are going to be going on when you revive this memory, but if you can weaken the arousal through the reconsolidation or the extinction process. We're also doing studies at NYU right now. We're trying to do non-conscious extinction, subliminal extinction, so that you could weaken the amygdala without the person consciously knowing the stimulus is even there and prevent flooding altogether.
Would a reward system that might be connected with establishing positive memory be not effective, while the amygdala fear system would be effective?
Well, there's a study that I wanted to do, and somebody beat me to the punch, but it's reconsolidating an aversive state with a positive one. So instead of, let's say you've got a tone paired with shock, and now during the reconsolidation window, you've retrieved the memory. During that, you pair the tone with food or something pleasant and change the memory. And so that's the memory you go forward with. It's like extinguishing, but instead you're putting a positive memory in. So instead of creating a safety signal through extinction, you're creating a safety signal through reinforcement. Yes?
Really 2 questions. One is, it seems like a lot of the soldiers, especially with complex PTSD from combat, it seems like every time they trigger, it's more like a kindling, like with epilepsy, rather than a fatigue or extinguishing. Would you address that? And the second question is some of the non-drug techniques for reconsolidation. I'd like to hear some of your thoughts on that as well.
So I'm sorry, I didn't.
The intense PTSD from combat trauma with complex PTSD. Yeah. It seems like some of those memories, every time you trigger them, they don't extinguish. They, in fact, are intensified, much like with epilepsy, right, with kindling.
So let me answer that. So what's happening is that you're talking about the conscious memories, and what the flooding is, what's happening in flooding is you're triggering, say, the amygdala or other structures like that unconsciously that are creating the arousal that is flooding the mind. So the mind is now in a runway, hyper-aroused, attention focused on the traumatic memories and so forth. So that's how it gets railroaded that way.
So you have seen that type of thing happening where every time you bring it up, it actually...
I'm not a therapist, I haven't seen
Okay.
anything.
Well, the second thing is you keep mentioning the non-drug ways of reconsolidation that modify. What are some of those that you're proposing along
Oh,
those
that was
lines?
the combining extinction with reconsolidation.
I see, okay.
I think we're going to have to stop there. One more? Oh, okay.
Talk about electric shock therapy and prefrontal lobotomy, and how did that fit into this model in terms of suppressing the
Right.
thoughts in a person with severe depression?
So the lobotomy I have nothing to say about, but reconsolidation was actually initially demonstrated through ECT studies in rats. So they found an amnesia after, if you have the rat retrieve the memory and then do ECT, then you block the storage and lose the memory, just as you impair the formation of new memories. Thank you all very much. It's been very good.
I just want to add to the applause by thanking you on behalf of the Health Science Center, the Ecumenical Center, and the Center for Medical Humanities and Ethics. And I would like to restate that out in the lobby, there are booksellers, and you may purchase copies of Dr. LeDoux's books, and he will be available for a brief period of time to perhaps sign some of these if you so desire. Thank you for attending Conversations about Ethics, and we are adjourned.
Trip is with 2 I's, T-R-I-I-P. That's great, Mom and Dad.